Hi everybody, my name is Phil. I'm from Logicworks and I'll be giving the seminar today on the automation in a cloud and DevOps world. We're taking a technical deep dive into the way Logicworks has implemented our automation framework and give you different steps on how we think you can do the same things in your environments. Just a little bit about Logicworks. Logicworks is a managed service provider that's been operating in various parts of the space for about the last 20 or 30 years. We've moved from being a ISP to being a managed hosting provider to being a private cloud provider, and over the last 5 years we've developed a strong expertise in AWS and the public cloud. Our services sort of are across the board in the cloud space. We help with cloud strategy and migration, basically like helping companies who are new to the cloud determine the best process and method for getting their workloads into AWS or other cloud providers. Creating a managed cloud service where we actually act as an extension of the client's IT department and provide managed services for all of their deployments. Provide assistance with regards to cloud security and best practices, and possibly our strongest suit is leveraging DevOps automation to basically build, automate, and manage enterprise clouds. So in this talk today, we're going to go through 4 sort of main areas. The first, and possibly most important, is why do we automate? What's our best practices? What are our reasons for doing so? What do we save time on by doing this, and what potential pitfalls can we potentially avoid by following an automated practice? We're going to take a technical deep dive into our actual automation practices so you can see some of the bits and pieces of how we make this all work and some of the lessons that we've learned in the process of assembling our automation toolkit. We'll talk about some of the security and governance benefits of automation and the different ways that we can use automation to help when we have to deploy PCI, HIPAA, or other compliant environments. And then finally, we're going to try to come up with some action items for your team to give you a sort of a guide to the ways that you can determine the best areas of your infrastructure to look at for automation and other DevOps development. Now, the days when IT departments managed a monolithic and frequently modified stack is long gone. Our applications have become substantially more advanced, and because of freeing ourselves from the limitations of hardware in the cloud environment, there's a lot more moving parts that we have to consider when we're coming up with a strategy for developing in the cloud. How do we efficiently manage the fact that these environments are constantly changing? Well, we like to think of it as the best opportunity is to use automation. So how do we use this automation to improve our infrastructure? We'll take a look for a little while at sort of the old way of doing things and the way it's changed in the current cloud environment on AWS. So it used to be that largely scaling and improvements were a matter of essentially throwing people and money at problems. You either needed more hardware if you wanted to scale, you needed more engineers if you wanted to automate things further, and you had far more complex processes that involved both hardware and engineers and software and automation. So in the new world of the cloud and the programmable infrastructure, we can develop smarter software to actually control the cloud and control the deployments. Now, we follow a few different principles when we're looking at DevOps in the cloud. The first, and probably the most important, is to design for constant change. A big part of developing the infrastructure we use to deploy the workloads that we provide to our clients was based on understanding the fact that the ground would be consistently shifting underneath us, that we needed to be comfortable in an environment where everything is changing and everything can change down the road. We weren't just going to look at how do we build an environment for a client, but also how do we manage that ongoing change sets that happen to that environment, and how can we do that in a way that's, of course, financially makes sense for both sides and also provides that sort of reusability that is the key to automation and development in this world. The next thing we would look at is to try to build repeatable components and not unique, perfect little snowflakes on every particular request that comes in. We need to be looking not just how do we service a individual stakeholder's concern, but how do we service it in a way that we can leverage again and again in the future when this issue comes up again. Another one of the more crucial aspects of this is also to anticipate failure. Now, oftentimes, some of the failure rates in the cloud get a little overblown when they're not compared directly to some of the things that we don't consider in the hardware space. Things like the chances of getting a bad batch of hard drives, or the chances of your power supplies failing, and all those additional elements of maintenance that are easy to forget. We're going to plan for all those things by leveraging some of the auto-scaling features of AWS to ensure that we have reliability and redundancy at all levels of our stack. And the fourth and final principle that we follow is that basically any amount of human effort, any amount of manual work is a security risk. And this is something that we want to avoid at all costs. Now, obviously, we're always going to have to be involved in the process at some level, but we want to always be looking for opportunities to reduce the chance of human error. Now, how do we design for constant change? This is possibly one of the more difficult things for people who are new to the cloud to really get a handle on and feel comfortable with. There is no completion date for most projects in the modern cloud-enabled data center. So some of the changes that we need to prepare for in every single instance we deploy is, first of all, how do we create these things in the first place? Whether we're creating a new environment, a new instance, or just a entirely new network architecture altogether, we need to prepare for how are we going to create it in the first place. The next thing we need to determine is how are we going to do rolling updates on those things? How are we going to update either the infrastructure details or even the OS configurations that enable how we use those particular infrastructure elements that we've created? We also have to be mindful of things like instance failures. When we're deploying EC2 instances, we can be mindful of things such as availability zones and so forth, but we always have to be prepared for the inevitable scenario where an instance will need to be terminated or moved to another location. We also, along those lines, we sort of group this in with capacity planning as well, because from the point of view of we feel a modern and fully automated installation on AWS, there's little difference between an instance coming up for the first time and an instance that is automatically being launched to replace an instance that previously failed, or to add additional instances to deal with capacity or load concerns. And then finally, we need to have, as our fourth major change that we have to be prepared for, is ongoing development. With most stakeholders that Logicworks interacts with, there's always at least some amount of custom software that was created in-house that has iterative changes being made to it, and that needs, in the modern software development world, needs a high development velocity, including things like continuous integration and continuous development. So what are some ways that we can deal with this environment when we're creating new things, or whether we're creating a new environment or new objects in an environment? Well, when we took the manual approach, some of the challenges were that this process could be slow. There were a lot of parts to put together. The process of creating all the objects we required and linking them up was slow and prone to error. We would treat every environment would be like, we keep talking about these snowflake environments. We want to avoid that. We don't want to be treating each, whether we're creating dev or creating QA, there really shouldn't be a lot of differences in those two environments, other than things like the number of instances or the size of the instances we've deployed. And so we want to make sure that, we're not reproducing that process, that we've created templates, and that we can really reuse as much of the work that we do up front down the road. The other thing we want to avoid is any sort of chance of forgetting crucial details. Now, whether you look at this as security or just some of the best practices in a build, we can only remember so much, and the more things that we have a responsibility for including in a design, the more difficult it can be to take a manual approach to this. On the flip side, when we're leveraging automated process, we can use pre-built templates. Within Logicworks, we have a strong what is now being called sort of an inner source philosophy, much like open source in the public world. Internally, we have a large repository of existing modules and tools that all of our engineers can use to customize a full CloudFormation manifest that can be then deployed to our users. So Over time, we've also developed a standard deploy process and other ways that make each new environment a very known quantity of what the process is going to be for us to create the objects inside. The other thing we're always conscious of is the instance lifetime, that every instance is going to follow a similar process in how it actually gets deployed. And for us, this begins with CloudFormation, and this is tied into the fact that we're going to be instantiating just, again, these pre-existing templates that have already been developed and tested and vetted internally. And so there's no snowflakes, there's no pets in this environment. Everything is just a cattle, that can be pushed through the chain and that can be easily replaced when needed. Now, the next thing we have to deal with is the fact that engineers often want to make changes to the infrastructure once it's been deployed. And this is perfectly reasonable, but it also has a series of challenges with it. Obviously, as we've discussed, there's human error is an ongoing issue whenever we're making changes. And if we're dealing with the fact that a particular infrastructure might have been pushed to production, it adds an additional level of complexity. So there can be a high risk of change in that environment, and then the actual process of making that change can be much slower because, again, a person has to go in and make a set of existing changes and then make that switch over. So this can be hours or days of engineering time that gets wasted, and we have no ability to roll back to a known functional state. Conversely, if we take an automated approach, we're changing the code that's on the servers and not really making major changes to the servers themselves, or we're taking steps that allow us to do things like rolling back deployments that have failed, and we can ensure that when we're finally done, we have each server contains a known state, an ideal configuration that is the minimum requirement for that server to function. Now, one of the things we use heavily, just as a quick glimpse, is as part of all of our automation chains, we leverage Git and other source control utilities as much as possible, so that whenever we're creating a set of changes in an environment, we have a very clear audit log of the changes made to indicate what actually happened to this environment. This is an actual screenshot from some work I did a few days ago, and it can be seen that at a very high level, what I was doing, and then each one of these changes correlates to some sort of event or some sort of request that came in from a client, or also subsequent requests that were discovered in the process of doing a build. But again, all these things are going into an existing template that means that future changes made will not have to deal with the regressions that were in place that had to be fixed here. In using this particular example, this SSM role will never need to be enabled again once it's been enabled in that original software repository. So configuration management is sort of the next step in the process. We've already talked about using things like CloudFormation to define a template to create your AWS infrastructure, but then the next step in it and some additional parts of this process is what we call configuration management. Now, oftentimes, configuration management refers to a set of tools that are actually increasing in popularity. The sort of set of the most popular configuration management tools at this time include Puppet, Chef, Ansible, and Salt. Puppet being the preferred language at Logicworks, but one that we chose largely because of the available skills on our existing staff. But configuration management is truly your best friend when you're working in the cloud. We're always working towards the reality in the cloud that to leverage the tools and the features that have been provided to us in the most efficient way, we need the ability to trivially rebuild instances that have already been deployed. So, we're, rather than creating a given instance, a specific instance, we're designing a template that defines what a proper instance should have. And so we can create and maintain these configurations in a very consistent and methodical way. So each instance gets configured in the same way, ends up in the same state, and then we also encourage the adoption of evolving standards by having a straightforward process for upgrading and migrating code from one version of the platform to another. Now again, we're still planning for constant change in the sense of failure. So in addition to the instance and component failure, we need to be cognizant of also how we're monitoring and alerting on these items as well. So currently, In a manual environment, there can be a set of alerts that have been defined by human beings, but then the human that actually receives the alert needs to take the appropriate action, either to rebuild the instance or start again from scratch. There's a high potential for downtime in this environment because it's very reactive. We don't actually deal with problems until they actually have failed, and we're not really working from a point of view that is planning for constant change and always planning for the possibility of failure. In an automated cloud environment, we're going to leverage things like auto-scaling groups to ensure that an instance that is terminated is immediately replaced with an instance that already has the recipe and the set of instructions it requires to instantiate all those pieces of software that were installed previously. So we can automatically rebuild a failed instance. We can automatically build new instances that might be added for capacity reasons. And we can also ensure that the code that is deployed to new instances is always at the most recent version of the push that was deployed to previous ones. So there's a lot of pieces involved here that ensure for us to have a very redundant and self-healing environment. Now, one of the misconceptions about AWS, because of the fact that they do already give you a great number of tools for high availability. We have availability zones within regions, and then we have multiple regions across various countries and geographic areas. Extremely high reliability of the EC2 instances that are deployed. Additional reliability from things like managed services like the RDS Managed Database Service. Obviously the auto-scaling groups that we've touched upon already, and low-cost disaster recovery is often billed as one of the tools that are available. The catch is, though, that these things are not all just built in. They're not just things where you're going to sort of sprinkle some fairy dust in and immediately have a high availability environment. There's some aspects of this that need to be planned out ahead. And the first is when to use auto-scaling groups. Now, one of the most common misconceptions about auto-scaling groups themselves are that they're meant exclusively for load-based scaling. The idea of, well, I just got this huge batch of traffic and I'm going to spin up new instances to support that traffic. While that is one of the features that's available in auto-scaling groups, we find that that's actually the least useful, or the least used part of this functionality. Auto-scaling groups can provide not just scalability, but also availability. So that means that if you need to be sure that you always have two instances of a particular kind deployed behind like a load balancer in some auto-scaling group, you can simply create a fixed size auto-scaling group. And this will ensure that when that instance gets terminated, it's immediately replaced with no actual human interaction involved. Now, there's some challenges with this because what we're really talking about is a very complex workflow of steps that needs to happen at the boot of an instance. Now, tools like Puppet and Chef and some of the other configuration management tools make this substantially easier, but you're still essentially writing a script that is going to have bugs, it's going to have to be vetted and tested, and without adequate testing, you lose some of the certainty around auto-scaling groups, and with an you lose some of the uncertainty that they will definitely come up and scale properly in the event of a failure. So it raises the question, do we always want to use auto-scaling groups? And like many questions, the answer is, well, it depends. The best scenario for auto-scaling groups is when you can create an existing AMI, an existing machine image that already has all the software that you need to run your environment. In fact, not just all the software, but also all the configuration data. If it needs to attach to a particular database, there should be some discovery method within that AMI that determines how it's going to figure out what that address is. Now, there's a lot of different ways to do this, but they're all dependent on your particular needs. And so that's where a managed service provider like Logicworks can come in, is helping you sort of navigate some of the various options that exist in this space. Not only do we work with Puppet, we also work with a wide variety of other configuration management tools. And so through that process, we've seen a lot of the potential pitfalls that can happen when you have a very complex boot process. Now, one of the most important things to achieve this is making sure that you have an appropriate amount of testing in place. So because of where we are in the development of cloud architecture. Right now, the only real way to be 100% sure that an instance will properly recover upon termination is to terminate it and to actually test that process. So we actually try to empirically prove the resiliency of your environment, and that can be done with a variety of tools, one of which, of course, is the famous Netflix Chaos Monkey. If you've never encountered this, this is a tool created by Netflix in the early days where they're really getting their AWS chops at a high level. And basically, Chaos Monkey is a service that runs and then arbitrarily terminates random instances in your environment. Now, not a lot of organizations are actually so fully invested in autoscaling and so forth that they feel strong enough to actually put this to use. But for those that do, this is a huge value in the sense that it really sends home the aspect that an instance can be terminated at any time, and you should know at the very least what's going to be the behavior of your instances when they lose connectivity or they lose availability of certain tiers of your environment. So this is a great way to expose unexpected failure scenarios, and it sort of brings us back to the key success criterion when you're developing autoscaling groups within EC2 is, are you engaging in destructive testing or not? Without destructive testing of the instances that we're trying to make self-healing, we're not at the point yet where we can really be 100% certain that those instances will scale themselves. So a good testing strategy, and possibly also things like disaster recovery, game days, and other kinds of planning can really help your overall availability over time. Now, the other design for constant change we have to be mindful of is the fact that there's ongoing deployment all the time. And this is one of the biggest areas of slowdown, the biggest areas that impacts your ability to actually push software at a reasonable rate. And this can have bottom line impact, especially for like a software organization that is dependent on being able to push changes, particularly whether it's software updates or new features, through their chain without much of a problem. And so the manual approach that's been used, as long as we've had software that needs to be deployed, is, still in use in many cases. We're doing a manual deploy where someone is actually visiting the instance that needs to be updated, the EC2 instance or whatever. They're pulling down new code, perhaps from Git or some other kind of online source. The infrastructure itself doesn't change. It's already set up. There's already X number of instances available. They already all have to be behind the load balancer at the same time. We can deal with things like potential conflict between packages, issues with updates. All these things could come into play when we're taking a very manual process for developing and deploying new code. Now, if we take a more automated process, the things that some often refer to as continuous integration or continuous development, we can get to an environment where we have push-button deploys, or even where, based on a simple code commit, we're automatically building and deploying a new version of the architecture. Also, with the advent of containers, Docker, Mesos, and other environments like that, the container approach can actually provide an even higher level of certainty around deploys, because many of these complicated steps that previously needed to happen at deploy time are now created at build time within a container. So long before a container is actually shipped to a production server, any sort of essential packages it requires have already been installed. So if there was a conflict, we would have fixed it at that point. So containers are bringing a lot of new options, but you can only truly leverage containers if you're also taking care to follow the other best practices along with deploying new code, which is, again, leveraging automated build scripts and very straightforward processes for creating new revisions of your code. Now, this is one particular tool that we often use during our integration with client third-party software, and that's the Amazon Code Deploy service. And one of the best advantages of Code Deploy is it provides the ability to scale your deployment process even to hundreds or potentially even thousands of instances. Code Deploy is sort of a two-step process where, first of all, you package up whatever resources or assets you want to ship to the EC2 instance into a zip file, which is then dropped in an S3 bucket along with a tiny little YAML configuration file that basically says what scripts or commands should be run at various phases of the deployment process. And then once that's in the bucket, a separate process tells the agent that is actually running on all of the EC2 instances in an autoscaling group or behind an ELB or with a particular tagging structure, tells all those instances that they need to pull this latest version of the code from their environment. The code is pulled into the EC2 instance, and the AppSpec YAML file is followed to determine what other kinds of steps need to happen. If we need to restart Apache or we need to copy a file from one place to another, all those things happen in parallel, and then we've deployed a large number of systems in a very short period of time. Additionally, this saves the current revision that has been pushed, so we have the opportunity to roll back to previous versions of the code. And it also tracks which version has been deployed to a particular autoscaling group. So if you have an autoscaling group that is scaling based on load, when that new instance gets added to it, it will automatically get the latest version that's been deployed to one of those previous existing instances. So code deploy is increasingly becoming a standard part of all of the deployment pipelines we develop with our clients. It slips right in as the last couple of steps in just about any chain, so it's definitely worth looking at for anybody who has to deal with this particular scenario of deploying code to instances in AWS. Now here's a little more complicated situation, at least on the surface. This is showing an example of leveraging Amazon ECS to deploy Docker containers across this environment. And the value of this is that ECS, in conjunction with the features of Docker, really take away a lot of the challenges that can come into play when you're dealing with a large number of applications deployed across a large infrastructure. In fact, specifically, there's an issue that came up most recently where our ECS agents, our ECS clients, actually had a much easier recovery process than some of our non-ECS or even Dockerized but non-ECS Dockerized environments. And that was with the recent kernel exploit for Dirty Cow. We actually have this need to not only update the current kernel version of all of our instances and, of course, restart all those instances as well, but also ensure that we have updated the backing AMI that is used for all these environments to ensure that the next time an autoscaling event happens, that the new instance that comes up already has that patch installed. And this is really a challenge for, I really feel this is a challenge for anyone on AWS and actually anyone on any sort of cloud environment at this time, because anytime you're going to be instantiating an instance from this pre-existing image, you have to have a way to trivially update that image without much of a problem. And if you're dealing with a very large environment, this requires coordinating restarts and things like that with different parts of that organization. So for our clients that have been leveraging ECS, however, this has been much easier, because for us, since ECS and at least the way we deploy is always connected to an autoscaling group of instances, we simply go through and we update the autoscaling groups so any new instances have the proper image, and then we just iteratively kill one node at a time until all the nodes have been replaced. And in fact, that even in itself can be automated, so that simply it'll just add one more instance and then gradually pull out all those previous instances. So in a one fell swoop, we're able to cycle a large number of instances without any observable downtime. So ECS is really a great opportunity for running Docker loads on AWS because of the fact that that crucial backing data store that is sometimes supplied by things like etcd and so forth and other environments can be used, is actually taken care of by AWS. So it adds an additional level of scalability and removes one more concern from the management of a highly scalable, redundant environment. So this sort of leads us into what is becoming increasingly a very prominent concept within the infrastructure and automation worlds, and that's the idea of disposable infrastructure. The core concept behind this is that it's expensive, time-consuming, and not to mention boring to fix a server. So why fix a server if we can get to a point where we can just throw it away and build a new one, or even, have one that's already ready to go that we built in seconds and then pop it right in. So this is a topic that comes up a lot when talking about Docker containers, because it is considered the conventional and the best practice way to develop a Docker container, is that the infrastructure as deployed never strays from its initial known good state. Nothing is ever written to the container in any, nothing that needs to be preserved anyways. And any logs that are stored there are shipped to some sort of central location, and that at any time these containers or even instances, when developed this way, can be terminated and trivially replaced. Now, this because this is tied into the actual lifetime of the instance, you are actually forced to test the failure process on a much more frequent basis. So this increases your certainty of an appropriate response during a failure. If you're actually testing the failure process every time you do a deploy, then that means that there's really little that can surprise you in regards to temporary failures or random errors in that sense. And so failure becomes a routine and continuous way of doing business. The only catch is that this requires full automation of the instance boot process, something that Logicworks has made a priority, particularly with regards to our ECS and Docker builds. So as a quick case study of disposable infrastructure, this is actually, this particular implementation wasn't even done with Docker, but is, of course, Docker's on the horizon for this particular organization. And basically, this it was an enterprise backup software company that hosted critical data for about 86% of the Fortune 500 companies. So they had a very high potential threat exposure, and they were highly risk averse. And they had this new application, and they wanted to really test the viability of immutable infrastructure. So in the process, Logicworks created a custom environment for them built from the CloudFormation template library. And this is actually really the first real deployment of our template library in a production sense, and since then has been used hundreds of times to do similar things in different industries and areas. And basically, we have these multiple templates for different projects and application components that have been mixed and matched to create a given architecture. Then for the EC2 environments, the EC2 instances that are deployed, the entire environment set of instances is blown away and rebuilt many times a day just as part of their deployment process to their test pipeline. So the entire build out and bootstrapping process happens in the order of minutes. So this gets them to a very what is a true representation of immutable architecture, is that it is very rare for them to be concerned with what is actually happening on a given instance. It's more a question of a particular kind of instance, and it's known that all of these instances will operate the same. This allows us to leverage this termination rate on a couple of different fronts. For example, like we were saying with regards to patches and updates, once a patch is put in place on the original AMI, we could be comfortable that all of the existing instances that are deployed for this environment get rotated out at least on a weekly basis, and then for production instances whenever a production release is made. So it substantially reduces their threat exposure and the vectors for attack. So the results of this have given them an extremely low instance failure rate, somewhere on the order of 1/1000%. They have 100% uptime for their production application. They've now been running for almost 2 years. They have a single-click process for deploying to production without any instance configuration tasks involved. There's no residual impacts if they have a previous failure or some kind of problem on a previous instance. They know that any new instance deployed is completely free of those previous issues. And then they ended up with a 60% higher deployment efficiency over other projects within the company. This was a huge win for an organization that was one of the first to this department within the organization was one of the first to really deploy the cloud, and they were able to really set a standard for how the rest of their organization went forward when doing their deployments, and it's all based around the idea of disposable infrastructure. Now, what are the security impacts of automation? Sometimes when people are thinking there's a lot of various things going on that they aren't directly responsible for, that somehow that increases their risk. But in fact, we find that using automation greatly reduces the risk of potential security flaws. Things like having a controlled and standardized build process means that once we've determined a step that needs to be added into our build process, we can trivially add it to every single environment pipeline that we've created. We have a controlled and standardized update process that is similarly effective, that if we need to push out an emergency patch to our environments, Things like our pre-existing Puppet architecture will allow us to do so in a very quick and straightforward process, and we can do so without having any sort of direct manipulation by a human being in this environment. Everything's sort of done by effect. We'll push a change to a particular repository, which causes a build of our CI/CD pipeline and pushes these configuration changes out to the Puppet master, or even just directly to the AWS API, however is appropriate. So again, we've reduced any sort of human involvement and greatly reduced the chance of error because of mistakes. This also helps with regards to patching. We're able to, in most cases, make an update to a central script and ensure that consistent versions are deployed across the environment. If new resources get launched with the old version installed, like we said, if we have some sort of base AMI that already has a version of a package, in most cases we can just use configuration management to correct that. There can be challenges, of course, with things like kernel updates and so forth, and this is an area that's still sort of in development for this space. I mean, it raises questions why, this is why we're going in the direction of immutable architecture. Is it's far easier to just replace an item that has with something that's been fixed than having to go through and fix everything in place. And then finally, a step that Logicworks has taken very seriously is the idea of proactive scanning of the environments that we deploy. And this is something that is a little more complicated because it leverages a central automation plant that we've defined that basically has the knowledge and the required access rights to basically iterate through all of the clients that we provide management services to, looking for particular flaws, mistakes, or common errors. Using this diagram as an example, you can see how we've got some security groups that are rather complex here. And if we had just one instance that arbitrarily had a security group open to the world, it might be difficult for us to find that. It's sort of a needle in the haystack kind of problem. So we have a series of tools that look for things like this. Look for open ports that have been open to the entire world. And basically, for more simple things, can actually fix them in place. For example, we ensure that all of our clients are using CloudTrail for API logging and AWS config for resource management. And this allows us to ensure that every single client we have that has objects created in a particular region have enabled CloudTrail and AWS config for that region. Similarly, there are other scanners that just look for problems that can be fixed by human beings, such as these open security groups, which would actually instantiate a ticket in our NOC and incite some engineer to go and fix this. So there's a lot of options that can be leveraged when you're really taking advantage of the fact that not only do you have an automated process for crawling across these different environments, but also you're dealing with a standardized automated build so that each environment has similarities that can be leveraged to make these automated tools work properly in the first place. Now, just to give you an idea of some of the tools that we use for different aspects of security automation, we find it mostly breaks down for us between either CloudFormation, used largely to manage AWS resources, and Puppet, used largely to manage operating system software and configuration. So for things like security groups, network ACLs, subnet sizing, and just the all-important naming of those items, we definitely leverage CloudFormation. This is actually one of the first things that we built in CloudFormation was a standard hub and spoke network architecture that we could use across all of our client builds. But then Puppet is particularly useful for the kinds of things that we need to install on the OS itself. Things like authentication tools to connect to like a central Active Directory server, encryption or antivirus software, and some of the essential things that Logicworks often takes care of for our clients, things like log shipping and aggregation, or ensuring that given versions of software are deployed. All these things can be easily automated and greatly reduce the amount of work that needs to be put into any given instance or update. So in summary, automation is great, and you should definitely do it. Of course, any step forward is great. You don't have to do it right now. It's important to find the things that work best for you. But if you do nothing else, start with configuration management. Make sure that for any instance you deploy in the cloud, you have a stable, robust set of instructions for how to build up that instance. This is going to get you the most advantages and get you the most payback out of your use of the AWS environment. So that's the end of my presentation. We did want to open up for a few questions and answers here. We'll take a few minutes if there's anyone would like to submit a question through the GoToWebinar process, please do. And do we have a couple of existing questions? Yeah, okay, here we do. All right, so the first question we just got was, why did we choose Puppet? And honestly, the answer for this is not particularly religious. We chose Puppet because that was what we had the most familiarity with. As a managed service provider who'd been through a lot of different technologies, we'd come across Puppet most often. And that was the one that at the time that we really started developing our standard practice, that was the thing that had the biggest community around it, seemed to have the most support. And some of the decisions we had to make as an MSP were more based around this idea that we have to pick things that are going to have the widest appeal to the most number of users. Even though there's sometimes tools that we might prefer or tools that are more interesting, we sometimes will pick the one that is going to be most useful for our individual clients. I have another one here. Why did we use CloudFormation and not Terraform? So anybody who's dealt with configuration management and other tools like this have come across some of this is a huge space, and there's a lot of things happening in it. And Terraform is probably the leader in the multi-cloud templating toolkits. And it is actually something that we're investigating independently because it's starting to come up more often. But basically, we chose CloudFormation because it seemed to have the best community support as far as like free support that was available to users. And more importantly, it had AWS behind it. The value of having a toolkit that is that is backed by a very, very large multinational corporation, I think is easy to overlook. Because basically, if we have a problem with CloudFormation, we can go direct to AWS and have them fix it. Whereas Terraform, although it's definitely becoming a prominent tool, it does tend to lag behind code releases a little bit. There can be some challenges there, but any tool that addresses the main goals of having configuration management and infrastructure as code is, in our opinion, a great option. Also, I just got a question as well about we'll definitely be sharing the PowerPoint, and we'll be sending this out to the emails that you signed up with, along with. Do we include a recording of the call? Yeah. So there'll be a recording of the call, and the PowerPoint will be sent out shortly. So you'll be able to go through all this. Is there anyone else who has any questions here that we can answer? All right, I guess that's it. It's been a real pleasure talking to everybody and doing this presentation for you. Please feel free to contact us at Logicworks if you have any questions. And as I mentioned, we'll be sending out a copy of this presentation along with a recording after the call. Thank you very much for coming, and have a great day.